All right, now we're doing 7Q, sum of integers in string. This is by King Cobra, and 93% of the people like it. So our task in this kata is to implement a function that calculates the sum of the integers inside a string. For example, in the string blah 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 blah, the sum of the integers is 3635. Note, only positive integers will be tested. All right. So as we see, this is a huge number compared to the number of digits here. So we're going to be adding up, pardon me, we're going to be adding up the full numbers that we find instead of just like 3 plus 0 plus 2 plus whatever, right? So first things first, we're going to have to sort through these two things. Sort through this, make sure we have to sort through the things that are not numbers and the things that are numbers. So let's come over here and do a for loop to start off with. So for, let I equals 0, while I is less than s dot length, we're going to say I plus plus. All right? And then we're going to want to put these numbers into something to add them, like a result or something like that. So let's say let result equals 0. But the thing is, we're also going to need some temporary, we're going to have a temporary string thing to put the 3 and then add the 0 to it. And then I'll show you. So we're going to do temp equals this right here. What else do we need? And we're also going to need an extra temporary file or temporary variable. So we're just going to say t equals nothing equals, or just going to say t right there. All right, to start off with. So let's just go through right now, and we're going to say if, let's say if s at I is not a number, or is a number, right? So how are we going to check if it is a number? So we're going to use the isNaN function. So the isNaN function determines whether a value is nan or not a number when converted to a number, all right? And so if we put in front of this, if we wrap this in parentheses, and then put in front of this isNaN, like that, it'll tell us if it's a number or not. But we're going to do the opposite. We're going to do that so that it actually tells us if it is a number, all right? Hopefully that makes sense to you. So we're going to come down here and we're going to say if it is nan, we're going to say temp plus equals s at I. So if it is not a number, if it is a number, we're going to add it to the temp, all right? But the thing is, if it's not a number, so we're going to come down here and say if, and then we're going to say isNaN s at I. So if it is not a number and right before it was not a number, isNaN s at I minus 1. So if it is if it is not a number and right before it was a number, what we're going to do is we're going to say result plus temp. But we're not going to leave it temp because temp right now is a string. What we're going to do is use the number constructor, which when called as a function, it performs type conversion to a primitive number. All right. So we're going to wrap this up and say result plus equals temp wrapped up in parentheses and number like this. All right. Pardon me. So right now we're putting that in there, and then we're going to change the temp back to an empty string. All right. So let's see what it looks like right now. Console.log result. Test it out. All right. So now we've got 12, 3, 5. So we're good to go down here, except for right here that's no good. So let's see why. All right. Let's do a console.log. T equals empty string. Let's put that right there. We're going to say console.log, and we're going to say s. All right, so let's test it out. So it's putting 12, it's putting 12, but it's not adding this last 4, right? Because it's looking for 16. So the reason for that is because we don't have that last not a number to check to put this number into there. So what we're going to do is we're just going to add it to the end. So we're going to come over here and just say s plus equals, hold on, let's take this out of here. And then we're going to say s plus equals, and then we're going to add a string a to it no matter what. All right, now let's do console.log s also, test it out. And you see now it's 12.4a, and we've got 16 down there instead of the 12. So let's just say return result. Test it out. And it works. All right, attempt it. And it's good. Hopefully this makes sense to you. Hopefully this makes sense. We're adding a to the s so that it checks, so that this happens even on the last one, no matter what. And that's basically it. That's basically it. And then every time we add it together, we reset the temp and all that stuff. Anyway, so obviously that's very sloppy and kind of a little hard to follow. We can do it another way. Let's comment this whole thing out so we can refer to it if we need to. And then let's come down here and say const, and then we'll take this, we'll put this here, say equals s, and then have an arrow right like that. We'll do console.log here so we can test while we go, and we'll start with s, all right? So let's test it out. So now we've got 12.4, hello world like this, and everything else. So what we're going to do here is we're going to replace everything that's NaN. We're going to replace everything that's NaN with a space so that we can split this thing up into an array later. So first let's turn everything that's NaN, that's not a number, into a space by using the replace method. So replace like this. If you don't know about the replace method, let's come up here, I got it open. It returns a new string with one sum or all matches of a pattern replaced by a replacement. The pattern can be a string or regex, and the replacement can be a string or function called for each match. We're going to be using the regex, all right? So for the regex, we're going to use, let me open this up, a new one, and this one too. For the regex, we're going to use a character class. Let me open this one up too. And we're going to specifically use this one, where's it at? This one, this uppercase D, which matches any character that is not a digit. It's basically the same as NaN, all right? So we'll say replace / D like that, comma, with a space. But the thing is, it's only going to replace it one time if you go to the replace method. If a pattern is a string, only the first occurrence will be replaced. So unless we make it replace more than once, it's just going to replace the one time. So let's come over here and we can go even further down and look at this thing, this global search. So when we put a G flag on there, it'll search more than one time. So let's put G like that, and now let's test it out and see what it looks like. All right, so now we've got a space everywhere. Let's leave the G out just so we can see what it looks like. Especially on this one. See, it only replaced one of them, the first one like that. So let's do it again like that with the G. Test it out. All right, so now we've got this. So now we're going to split it by these spaces so that we can put each one of these in its own element, all right? So to do that, we're going to use the split method, which takes a pattern and divides a string into an ordered list of substrings by searching for the pattern, putting the substrings into an array, and returning the array. So we're going to split by the spaces, just like this one did, and this one puts every word in its own thing. So that's what we're going to do down here. We're going to say dot split like this by the spaces. All right, now let's see what we got. All right, so now we got 12.4, we got empty string 3, empty string 0, 0, empty, 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 all the way like that. So now we're going to use the reduce method so we can sum all the elements inside the array, all right? So if you don't know that about the reduce method, it executes a user-supplied reducer callback function on each element of the array in order, passing in the return value from the calculation on the preceding element. The final result of running the reducer across all elements of the array is a single value, all right? The first time that the callback is run, there's no return value of the previous calculation, but if supplied, an initial value may be used in its place. We will be using an initial value because if we don't, the array element at index 0 will be used as the initial value. And right now, whatever's at index 0 is a string, so we can't be summing strings like that. So what we're going to do is we're going to say dot reduce. And let me show you the syntax we're going to use. We're going to use this accumulator, current value, and then initial value. So right here, this is everything we're going to add to it, and this is the current value. So whatever is at the current element. So we're going to do this. We're going to say acc right here, comma, cur like this for accumulator and current value. And then we're going to have the comma 0 for the initial value. And so right here, we're going to say acc plus cur. But to turn the current value from a string into an actual number, we're going to wrap it with the number constructor like this, all right? So now, let's test it out. We've got some actual digits, some actual numbers. So 16 equals 16, 3 equals 3, 5 equals 5. So that's all good. We're just going to get rid of this console.log, test it out. All right, everything's good, attempt it. And it's good right there. So now you can choose any way you want. Let's submit it. Right here you can see they're using the match instead of what we did. We should have did this. Anyway, whatever. This basically did what we did, except that they used a map to change the numbers into numbers, the strings into numbers before reducing it down. This one here did the match again, and you can just check out all the rest if you feel like it. Let's go over to mine. Just me on this one. Best practice in my opinion. Very much like it. And we can see you next time. We'll see you next time.